Hey, good peoples. So let's do a little bit of section 1.4, which has to do with equations of the line. So first things first, if you recall, we were discussing the slope-intercept form in the last video, y equals mx plus b, where m is the slope and the b is the y-intercept. Right? Now, other key thing you want to kindly remember is that in applied context, applied meaning, real life situations, that the m is the rate of change and the b is the initial value when x equals to 0. All right, so just remember when we're kind of dealing with applications, you might want to keep that in mind. So, first application example is a plumber charges $65 for a service call plus $30 per hour for each hour spent on the repair. Assuming his service call charges can be modeled by linear function of the number of hours spent of the repair, write the equation of the function. So this is very kind of similar. So he charges 65 bucks off the top, right? Plus, keyword here is the plus, right? Plus $30 per hour. So $30 per hour plus a $65 service call. So that's our equation right there. Y equals to 30x plus the 65. Okay? Keywords again, the plus meaning the plus, per meaning is a multiplication, right? And our charges were the 65. The point slope form of the equation of the line. We use this, moving on to the next topic. We use this to find the equations of the line if we were given a point and a slope. Again, the slope is your m, right? And the point is any known point that we have. That's x of 1, y of 1. All right? This is a formula that we will use. Y minus y of 1 equals to m times x minus x of 1. So we have our first example here. It says write the equation for the line that passes through the point 4, negative 4, 6, and 1/4. So again, this is my slope. So this is your m. This is your x of 1. This is your y of 1. I just like to label my points sometimes. Okay? So if I plug it into the equation, this should be y minus 6 equals to 1/4 times x minus negative 4. Okay? So now we always, even when we're trying to find the equation of the line, most of the time we're trying to put it in the slope-intercept form. Remember, slope-intercept form is what? That looks horrible. Y equals to mx plus b. That does not look like that. So we have to simplify. So I would distribute the 1/4 and say y minus 6 equals to 1/4 x, right? Two negatives make a positive, times, what is that? 4 over 1. So that'd be plus 4 over 4. Now you're wondering, how did I do that? So 1/4 times 4, right? Well, this 4 is over 1, and then this is 4 over 4, and 4 over 4 is just going to give me 1. So y minus 6 equals to 1/4 x plus 1. Still not in total slope-intercept form, so we'll add a 6 to both sides, and y equals to 1/4 x plus 7. Okay? So this is, again, what happens when you're given a slope and a number or a order pair that it passes through. Now, if we do one more example, in my next example, I'm giving you 2 points and no slope. So if you are given 2 points, no slope, that means you have to go find the slope first. Okay? So label your points: x of 1, y sub 1, x of 2, y sub 2. So we end up doing, for the slope, 7 minus 3 divided by 4 minus negative 2. Okay? So 7 minus 3 equals to 4. And 4 plus 2 is 6, which gives us a 2/3 once we reduce it. But we're not done because we're actually looking for the equation of the line. So we have to plug it into the formula. Y minus y1 equals to m times x minus x of 1. So this now gives us, we can pick our points here, okay? So that should be y minus 3 equals to 2/3 times x minus negative 2. So just as we did before, we have to distribute the slope. So this should give us y minus 3 equals to 2/3 x. And then 2 negatives here make it a positive. But 2/3 times 2 gives me a positive 4/3. Then we need to add 3 to both sides. Okay? And when we add 3 to both sides, y equals to 2/3 x plus, we can do times it by 3, times it by 3. What is this? 4/3 plus 9/3. 4 plus 3 is 13/3. Okay? Gotta practice on some old school math there. All right, so really quickly, because my time is really rolling, an application example. All right, the table gives the number of drinks and the resulting blood alcohol percent for a 180-pound man. One drink is equal to 1.25 ounces of 80 proof liquor. Ooh-wee. So 12 ounces of regular beer and 5 ounces of table wine. Not sure who drinks table wine. Many states have a set 0.08 as the legal limit for driving under the influence. So we have this chart here, and our first question asks us, what is a rate of change of the blood alcohol percent for a man who is 180 pounds? What is it? What is that rate of change? So if I start looking at the rate of change, remember the rate of change is your slope, right? So in between these numbers, 3, 4, 5, 6, 7, 8, 9. So we can already say our change in x, right? Your change in x is only going to be 1, right? But now looking at our y values, do we see a pattern or a change within our y values? It goes from 0.02 to 0.09. Then from 0.09 to 0.11, 0.13, 0.15. Hopefully you're over there noticing that this has a change in y, right? And it is increasing by 0.2. Okay? So if we talk about a slope, remember it's the change in y over the change in x. So our change, or our rate of change, right, should be 0.02. Again, if you don't see it, the rate of change of y divided by the rate of change in x. So 0.02 divided by 1 gives me just simply 0.02. Okay, so that is our rate of change. Whew. Write the equation in the function that models the blood alcohol percent as the function of the number of drinks. So you can select any one of these points. You can select this one, you can select this one, this one, this one, this one, this one, this one, this one. Does not matter, long as you label your points and plug it into the formula. Again, the formula to find the equation is y minus y1 equals to m times x minus x of 1. So this, I'm just going to go by the first points, all right? This is your x of 1, this is your y of 1, and my slope is 0.02. So we have y minus 0.07 equals to 0.02 times x minus 3. Okay? I'm using these points right here to plug in. So once I've done that, I have y minus 0.07 equals to 0.02 x, right? Just make sure I'm not tripping, times 0.022 times, what is this, 3? And I got 0.06. Just make sure I wasn't tripping. So that'd be minus 0.06. Add 0.07 to both sides. And we end up with y equals to 0.02 plus 0.01. Okay? All right, so last application or example that we have here for today. So the number of people in millions in the U.S. prisons or jails grew at a constant rate from 2001 to 2013, with 1.345 million people incarcerated in 2001. That's supposed to say 2001. And 1.570 million incarcerated in 2013, right? What is the rate of growth of people incarcerated from the time period from 2001 to 2013? So, you have to say rate of growth again means, what does that mean, you guys? You should be ringing your head. That means a slope. Slope meaning you have a change in an x and a change in a y, right? So if I'm looking at this, I can say that 2001, 1.345 would be my first ordered pair, right? And then in 2013, we had 1.570, right, million people. So this will be my ordered pairs, and now we plug it in to find the slope. So we would do 1.570 minus 1.345 divided by 2013 minus 2001. So if we plug it into our fancy dancy calculator, we would have 1.50 minus 1.345, and then we would divide that. If you don't know, let's go real quick. 2013 minus 2001 gives me 12 years. So I'm going to do 0.225 divided by 12. And I end up with some unfavorable numbers such as this. All right. So I end up getting 0.1875. That is my slope. That's not pretty though. Okay. Then it says write the linear equation that models the number n of prisoners for the function of the year. So now it wants the equation of that, the linear equation of that. Well, you know how to do that. So at this point, remember y minus y sub 1 equals to m times x minus x of 1. Long as you have a slope and a point, anything is possible. So I am just going to pick the first point that we have here, which is 2001 and 1.45. I'm sorry, 1.345. So if I do this, then y minus 1.345 equals to 0.01875 times x minus 2001. Okay, now we must distribute, and we have y equals to 1.3, not y equals, y minus 1.345 equals to 0.01875 x. Distribute. Then we distribute here, right? So then we do 2001 times 0.01875, right? And that hit equals, and we end up with 37, 37, holy, I can't remember. 37.51785. 37.51819. Ms. Parker's forgotten just that quick. 519. So let's just say 519. I'm just going to go ahead and round it for my sake. All right. So now we get to add the 1.345 to both sides. And then y equals to 0.01875x. And then our number for our y is, hold on, let's see. That's that number. Now we're going to take that and make it a negative 37.519, as I put, plus 1.345 gives me a negative 36. Negative 36.174. Okay. And then that's it. Okay. So we've gone over quite a bit today. In this video, we still have quite a bit left for 1.4.